how quantum mechanics is different from classical mechanics, है ना? How quantum mechanics is different from classical mechanics. It is the basis of quantum tunneling. क्या है क्वांटम टनलिंग? यदि एक डायग्राम बनाया जाए इस तरह से कि ये this point is 0 and this point is D, or this is your x-axis and here it is the y-axis. तो y-axis का ये पॉइंट है, इस पॉइंट को हम कह दें the potential is V0, और कोई एक पार्टिकल है ये इस तरह अप्रोच करे, this is the potential and term as potential barrier. ठीक है, ये पार्टिकल अप्रोच करे तो इसमें जो पॉइंट है ये बैरियर को यदि सेंट्रल रीजन कह दें, सेंट्रल, तो ये हो जाएगा दिस इज योर लेफ्ट एंड दिस इज योर राइट, सेंट्रल का लेफ्ट में और सेंट्रल का राइट में. तो सेंट्रल के लेफ्ट से कोई पार्टिकल, एनी पार्टिकल which mass is m, energy is E, approaching to the potential barrier, then after the interaction with the barrier, what will happen? When the particle of mass m and energy E approaching towards the potential barrier, then there are two possibilities. First possibility क्या होगा? When energy of particle is greater than the potential barrier, तो क्या होगा? Particle cross the barrier. Or second, when energy is less than V0, the particle does not cross the barrier. ठीक है, क्रॉस द बैरियर है ना? कब? क्लासिकली. लेकिन if the particle is micro object, if the particle is micro object, then it will cross the barrier किसकी वजह से? This is the quantum इफेक्ट की वजह से, है ना? मतलब क्या है कि क्लासिकली इसकी प्रोबेबिलिटी 0 होगा, मतलब प्रोबेबिलिटी 0 क्लासिकली, बट क्वांटम मैकेनिकली प्रोबेबिलिटी 0 नहीं होगा. देयर इज अ फाइनाइट प्रोबेबिलिटी, that is known as finite प्रोबेबिलिटी, ठीक है, फाइनाइट प्रोबेबिलिटी। तो ऐसा क्यों होगा? नाउ द क्वेश्चन इज why we have the finite probability of finding the particle after the barrier when energy is small। जैसे एग्जाम्पल के लिए एक्सपेरिमेंटली प्रूफ्ड है, एक्सपेरिमेंटली जैसे अल्फा डीके है। अल्फा डीके का मतलब कि अल्फा पार्टिकल यदि न्यूक्लियस में है, दिस इज द न्यूक्लियस, और यहाँ पे प्रोटॉन्स है और न्यूट्रॉन्स है, तो अल्फा पार्टिकल का क्या होगा? अल्फा पर 2He4 हीलियम का न्यूक्लियस में इलेक्ट्रॉन नहीं होगा, तो ये अल्फा पार्टिकल। सो इट कम्स फ्रॉम द न्यूक्लियस, it comes from the nucleus, so there is a finite probability, ठीक है। और कुछ ये तो अल्फा का हो गया, कुछ ये है कि सेमीकंडक्टर जंक्शन, सेमीकंडक्टर जंक्शन जिसके आधार पर कि यदि ये जंक्शन है और ये पोटेंशियल बैरियर है, सपोज दिस इज द पार्टिकल जिसकी एनर्जी कम है, तो भी ये बैरियर क्रॉस करके इस साइड में आ जाता है। एंड देन देयर इज ए कॉन्सेप्ट ऑफ लीकेज करंट, लीकेज करंट, ठीक है, लीकेज करंट जैसे। तो कुछ ऐसे है हमारे पास एविडेंस कि एनर्जी कम होने के बावजूद भी दूसरे साइड में पार्टिकल के पाए जाने की संभावना है। तो इस कॉन्सेप्ट को, इस एक्सपेरिमेंट को एक्सप्लेन करने के लिए जो हमारे पास थियरी है, उस थियरी को हम आज डिस्कस करना चाहते हैं। दिस इज द अगेन सेम द बैरियर V0, here x is equal to 0 and x is equal to d, means the width of this one is, here it is left, this is center, and here it is right. So the mathematical expression, for the potential is as Vx. Vx is equal to 0. Vx is equal to 0 for x is less than 0. That is left side. And this is V0 for 0 is x less than is d. This is your central side. And this is 0 for x is greater than d. तो जो पोटेंशियल है उसको हम मैथमेटिकली इस रूप में लिख सकते हैं, और इस पोटेंशियल के आधार पर हम इसका एनालिसिस करेंगे। तो दी श्रोडिंगर इक्वेशन for one dimension in x axis is expressed as d2 psi by dx square plus 2m h cross square v minus this psi is equal to 0, and this is equation 1. This is equation 1, Schrodinger equation. So the solution the solution of this equation can be written as, first we can check left side, here it is central, and then right side. तो लेफ्ट साइड का जो सोल्यूशन होगा, दिस इज psi lx. Psi lx is a e raised to the power I alpha x plus b e raised to the power minus I alpha x. ये तो लेफ्ट हैंड साइड का हो गया. Psi central x is c e raised to the power beta x plus d e raised to the power minus beta x. And the right side, psi r x is equal to a dash e raised to the power I alpha x plus b e raised to the power minus I alpha x. I alpha x. ये हो गया इक्वेशंस. अब इस इक्वेशंस में हम ये लेकर के चलेंगे कि a है, this a represents the particle. Suppose this is the particle and this particle is moving in this direction towards the positive x. Here it is the x. So towards the positive x यदि ये जा रहा है तो this is represented by a e raised to the power I alpha x. ये टर्म जो है, this is b e raised to the power minus I alpha x. ये टर्म्स रिप्रेजेंट करता है जब पार्टिकल यहाँ जाए और ये टकराए और टकरा के जब वापस आए, है ना, कुछ पार्टिकल रिफ्लेक्शन. सो दिस इज रिफ्लेक्शन. This is reflection part or this is incident part. Incident part. इसके बाद central part में भी this part is represented incident and this part is reflected. Reflection कहाँ से? When this particle enter into the potential region, so this potential region is very something this. So if the particle is moving in this direction, so it is incident, then it is C, and if it is reflected back, then it is D. So if we write the coefficient, then here. Now the right side, this A dash is potential when the particle is moving after penetrating A dash. So this one is A dash in a positive direction. And this is the terms that the particle is coming here. Here, that is B dash. So in this case, we say that particle is moving from left, center and right. Left, center and right in this direction. The motion of particle in this direction. So there is no particle are approaching from right to center. And no particle is approaching from right to center. Then B dash coefficient is 0. B dash coefficient is 0. So this part is 0. This part is 0. Finally, what we have? We have the equations, that is central, left. This is left. Here it is central, and this is right. Left, central, right. So the equation psi left of x is a e raised to the power ix plus b e raised to the power minus I alpha x. And this is central C. X is equal to c e raised to the power beta x plus d e raised to the power minus beta x. And here it is psi right x is equal to a dash e raised to the power I alpha x. So these are the final equations. And these final equations are termed as equation number 3 for the given condition. अब इस इक्वेशन में हम इक्वेशन बाउंड्री कंडीशन लगाते हैं. बाउंड्री कंडीशंस. बाउंड्री कंडीशन का मतलब हो गया कि जैसे ये पोटेंशियल है बैरियर, तो ये पार्टिकल जाएगा, यहां से गया और इस तरह से गया. So at this point when x is equal to 0, this point x is equal to 0, the function exists. So at x is equal to 0, the function psi L left 0 is equal to psi central 0, है ना, this condition. तो psi left का मतलब हो गया this is a e raised to the power I alpha 0 plus b e raised to the power minus I alpha 0 is equal to c e raised to the power beta 0 plus d e raised to the power minus beta 0. So e raised to the power 0 is 1. So a plus b is equal to c plus d. Yeah. And similarly, this side also means x is equal to d. X is equal to d. So psi central d is equal to psi right of d. तो इक्वेशन क्या हो जाएगा? c e raised to the power beta d plus d e raised to the power minus beta d is equal to a dash e raised to the power I alpha d. ये केस हो गया. और दूसरा, यदि ये फंक्शन के साथ लागू है तो फंक्शन के डेरिवेटिव में भी लागू होगा. तो डेरिवेटिव ऑफ द फंक्शन, डेरिवेटिव of the function, functions, derivative of the function का मतलब psi dash L0 is equal to psi dash central का 0, और यही चीज यहाँ पे भी होगा, psi dash central D is equal to psi dash right of D. तो डेरिवेटिव क्या होगा? e raised to the power I alpha, तो I alpha यहाँ मिल जाएगा. तो a e raised to the power I alpha x I alpha plus b e raised to the power minus I alpha x minus I alpha x is equal to c e raised to the power beta d beta. This is x. This is x, so we have to take it is x, and d e raised to the power minus beta x minus beta. And substituting 0, this one is the derivatives at the x is equal to 0. So this value is 0. So this is a into I alpha minus b into I alpha is equal to c. This is c into beta. Here it is minus beta d. ये हो गया आपका So what we'll find, this is A minus B. A minus B is equal to, this is your beta upon I alpha, beta upon I alpha C minus D, beta upon I alpha C minus D. तो ये तो हो गया लेफ्ट में, राइट में सेंट्रल के साथ डेरिवेटिव निकाल दें तो दिस इज C e raised to the power beta D into beta plus, here it is plus D e raised to the power minus beta D minus beta is equal to A dash e raised to the power I alpha D I alpha. So what we find here is this is if you take beta common, so C e raised to the power beta D minus D e raised to the power minus beta D is equal to I alpha, this is I alpha A dash e raised to the power I alpha D, or C e raised to the power beta D minus D e raised to the power minus beta D is equal to I alpha upon beta A dash e raised to the power I alpha D. ये तो इक्वेशन का नाम रख दिया जाए, दिस वन इज इक्वेशन 3, ये क्या होगा, दिस इज इक्वेशन 4, और a प्लस बी इज इक्वल टू सी प्लस डी इक्वेशन 4, और a माइनस बी इज इक्वल टू बीटा अपॉन आई अल्फा, दिस इज इक्वेशन 5, ये इक्वेशन 5 हो गया, और दिस इज इक्वेशन 6, c e raised to the power beta d plus d e raised to the power beta d is 6, and here it is the equation 7, and this equation 7 is c e raised to the power beta d minus d e raised to the power minus beta d is equal to I alpha beta a dash e raised to the power I alpha. तो इससे हम क्या निकालेंगे, इससे हम यहां से 4 और 5 से a और b की वैल्यू निकालेंगे, और 6 और 7 से c और d की वैल्यू निकालेंगे. So let us do this exercise. From equations 4 and 5, we have what we have, a plus b is equal to c plus d, or a minus b is equal to this is beta upon I alpha c minus d. Yeah. So if we take common, or this one is b, it is not beta, it is b, a minus b. So what is the a? If adding these equation, we have what we have, this is 2a is equal to this plus b or minus b cancel हो जाएगा, a plus a is 2a, and here it is c plus d plus beta I alpha c minus d. So c is common here, so this can be written as 1 plus beta I alpha is equal to c plus 1 minus beta I alpha into d. This one is, so this is your 2a. So what is a? A is equal to alpha beta. So here it is I alpha plus beta upon 2 I alpha c plus I alpha minus beta 2 I alpha d, ये हो गया ए का मान। और दूसरे केस से दिस इज द इक्वेशन 5 and 6, and from equations 7, 4 and 5, 6 and 7, from 6 and 7 में क्या था? This is your c e raised to the power beta d plus d e raised to the power minus beta d is equal to a dash e raised to the power I alpha d। और इसका डिफरेंशियल जब लिए थे तो ये आ गया था विथ माइनस सी ई रेज टू द पावर बीटा डी माइनस डी ई रेज टू द पावर बीटा डी इज इक्वल टू आई अल्फा अपॉन बीटा ए डैश ई रेज टू द पावर आई अल्फा डी ए रेज टू द पावर आई अल्फा डी। So in this case, if we like to have adding these equations, तो ये प्लस डी और माइनस डी ये पूरा टर्म कैंसिल हो जाएगा, तो ये हो जाएगा 2c e raised to the power बीटा d is equal to, इसको ऐड जोड़ दे तो दिस इज 1 plus I alpha beta a dash e raised to the power I alpha d, and here it is c. So this c is equal to this is I alpha plus beta divided by this 2 beta, this beta is here, a dash is here, and e raised to the power beta d है वो डिवाइड करेंगे तो ये माइनस होगा, तो दिस इज I अल्फा माइनस बीटा डी है ना, ये टर्म से डिवीजन होगा तो देयर इज अ बीटा and d is common. So we can have c is equal to I alpha plus beta upon 2 beta a dash e raised to the power I alpha d। अच्छा, अब इसी को सब्ट्रैक्ट करें तो हम d की भी वैल्यू प्राप्त कर सकते हैं। सब्ट्रैक्ट करने में दिस वन इज कैंसिल और हियर इट इज एडिशन, तो ये होगा d is equal to, सब्ट्रैक्ट करेंगे तो this is the minus, so we can have this minus sign I alpha minus beta upon 2 beta a dash e raised to the power I alpha, this is minus beta तो यहाँ पे ये प्लस बीटा हो जाएगा, and this is d I alpha d। तो this one is the solution। तो इक्वेशन यहां से ये सॉल्व करेंगे तो दिस वन इज इक्वेशन नंबर 8 और ये c का मान आ गया इक्वेशन नंबर 9 और ये हो जाएगा इक्वेशन नंबर 10, 9 और इक्वेशन नंबर 10। तो यदि c की वैल्यू इक्वेशन 9 से, d की वैल्यू इक्वेशन 10 से इक्वेशन 8 में भर दें, ये c की वैल्यू और ये d की वैल्यू, तो हमें a का कंप्लीट वैल्यू मिल जाएगा। सो सब्स्टिट्यूटिंग values of c and d from equations 9 and 10 in equation 8. In equation 8 we have, क्या हम we have करेंगे, a is equal to I alpha plus beta divided by 2I alpha, c is this much, C is this much, मतलब I alpha plus beta upon 2 beta A dash e raised to the power I alpha minus beta D, I alpha beta D plus दूसरा पार्ट क्या है, I alpha minus beta upon 2I alpha and D का मान ये पूरा, this is the value of D. तो D का मान रख दें तो ये हो जाएगा, this is minus I alpha minus beta A dash upon 2 beta into e raised to the power I alpha plus beta D. ये this one is the equation. ये D का मान और ये C का मान भर दिया. अब इसको सिंप्लीफाई करें. If we simplify, then R if we simplify, then this A is equal to, this A is equal to I alpha plus beta, I alpha plus beta का whole square A dash upon 4 I alpha beta e raised to the power I alpha plus I alpha minus beta D minus I alpha minus beta whole square upon 4 I alpha beta A dash e raised to the power I alpha plus beta D, I alpha plus beta D. ये इस एक्सप्रेशन में वी हैव सम कॉमन, जैसे जो A डैश है, दिस A डैश इज कॉमन दोनों साइड में, 4I alpha common and e raised to the power I alpha D is common. So we can express this A is equal to A dash e raised to the power I alpha D 4 I alpha beta, and inside the bracket, what bracket, I alpha plus beta whole square into e raised to the power minus beta D. और इस टर्म में भी this is I alpha minus beta whole square, ये रहेगा ही, और इसके साथ e raised to the power beta D. ये this one is the value that is here. अब इस ब्रैकेट के वैल्यू को यदि हम एक्सपेंड करें, एक्सपेंड करने का मतलब दिस इज I स्क्वायर अल्फा स्क्वायर प्लस बीटा स्क्वायर प्लस 2I अल्फा बीटा और विथ ब्रैकेट e raised to the power minus beta D minus this is I square alpha square plus beta square minus 2I alpha beta e raised to the power beta D. ये हो गया. अब इसमें I स्क्वायर अल्फा स्क्वायर प्लस बीटा स्क्वायर ये कॉमन ले लें तो हो जाएगा I स्क्वायर अल्फा बीटा स्क्वायर, कॉमन ले लें तो ये हो जाएगा ब्रैकेट में e raised to the power बीटा D माइनस e raised to the power माइनस, this is minus, here it is plus D. ये और बचा क्या, प्लस 2i अल्फा बीटा माइनस 2, तो माइनस और माइनस प्लस, तो ये हो जाएगा 2i अल्फा बीटा और माइनस माइनस प्लस था तो e रेज टू द पावर माइनस बीटा डी प्लस e रेज टू द पावर बीटा डी. ये this is the case that we have find. इसको फिर से एम्पलीफाई करें तो i स्क्वायर इज -1, दिस i स्क्वायर इज इक्वल टू -1, तो ये माइनस, तो माइनस साइन हम कॉमन ले लें तो अल्फा स्क्वायर माइनस बीटा स्क्वायर, दिस इज अल्फा स्क्वायर, दिस इज अल्फा स्क्वायर माइनस बीटा स्क्वायर, अल्फा स्क्वायर माइनस बीटा स्क्वायर, और ये ब्रैकेट हो जाएगा e रेज टू द पावर बीटा डी माइनस e रेज टू द पावर माइनस बीटा डी, ये प्लस 2i अल्फा बीटा e रेज टू द पावर बीटा डी प्लस e raised to the power minus beta d. Yeah. So these functions, this exponential function is hyperbolic function. This exponential function is hyperbolic function. और ये hyperbolic function को हम, इस hyperbolic function को हम simplify कर सकते हैं. कैसे simplify कर सकते हैं कि यदि ये जो factors हैं, ये है a डैश e रेज टू द पावर i अल्फा d अपॉन 4i अल्फा बीटा, and here it is again the same a dash e raised to the power i alpha d upon 4 I alpha beta, and this is a dash e raised to the power I alpha upon 4i alpha. So here it is 2i alpha, here it is 4. तो इसको हम यदि अंदर ले जाएं तो ये कैंसिल हो जाएगा, ये कैंसिल हो जाएगा. तो यहाँ पर a dash e raised to the power I alpha d by 2, ये रख दे और इसको करें तो ये कैंसिल होगा, और तब हमारे पास ब्रैकेट में आ जाएगा, ये फर्स्ट ले लें बीटा डी प्लस e raised to the power माइनस बीटा डी, ये हो गया, एंड दिस इज प्लस अल्फा स्क्वायर माइनस बीटा स्क्वायर अपॉन 2i अल्फा बीटा, and then e raised to the power beta d minus e raised to the power minus beta d. Yeah, this one is a function. अब hyperbolic function की बात करें तो this is a dash by 2 e raised to the power I alpha d is, this is nothing but if we take this 2 inside, तो ये क्या होगा, this is 2 cos hyperbolic beta d प्लस यहाँ पे अल्फा स्क्वायर माइनस बीटा स्क्वायर अपॉन 2i अल्फा बीटा इंटू 2 साइन हाइपरबोलिक बीटा डी, 2 साइन हाइपरबोलिक बीटा डी, ये हो जाएगा. सो दिस ये 2 और ये 2 और ये 2 कैंसिल हो गया, तो a डैश e रेज टू द पावर I अल्फा d ब्रैकेट में cos हाइपरबोलिक बीटा d प्लस अल्फा स्क्वायर माइनस बीटा स्क्वायर अपॉन 2i अल्फा बीटा इंटू साइन हाइपरबोलिक बीटा d. This is a coefficient. This is the coefficient a, and this equation is say equation number 10. This is equation number 10, and this one is a very important expression as well. तो इस expression से हम ले taking the square of the modulus of the right hand side, we get is A amplitude mod square is here, it is A dash mod square, and this is cos hyperbolic square BD plus alpha square minus beta square upon 4 alpha square beta square into sine hyperbolic square BD. This is for the larger barrier thickness, beta D is greater than equal to 1, then cos hyperbolic beta D is equal to sine hyperbolic beta D is equal to 1 by 2 e raised to the power beta D. This is 1 by 2 e raised to the power beta D. This is beta D. Or A square is equal to this mod square into cos hyperbolic square beta D. Cos hyperbolic square beta D. So this is A dash square, and this is 1 by 2 e raised to the power beta D ka whole square. So this is mod A dash whole square 1 by 4 e raised to the power 2 beta D. E raised to the power 2 beta D. This is the A square. This is the A square. Therefore, this is the equation number 12. This is the equation number 12. So therefore, the transmission coefficient, transmission coefficient is given by transmission coefficient T is equal to A dash by A. A dash is the coefficient on the right hand side, and A is the incident, transmitted or incident, this part, and whole square is equal to, this is A dash upon this whole square is equal to 1 upon, this is 1 upon 1 by 4 e raised to the power 2 beta D, e raised to the power 2 beta D. So this is 4 e raised to the power minus 2 beta D, e raised to the power 2 beta D. Or this is transmission coefficient is, this is exponential minus beta is 2m upon h cross square v minus e, that is beta into D. So this is the T. This is your T. T is the transmission. So this is equation number 3. Now the coefficient of transmission, is given as T is equal to A dash by A whole square is equal to exponential of minus 2m upon h cross square v minus e into d, which shows that there are finite probability of the particle, penetrating the potential barrier when energy E particle is less than barrier, and this is called as tunneling effect. This is called as tunneling effect. The graphical representation कैसे होगा tunneling का? This is the potential barrier. This is 0, x is equal to 0, x is equal to d, left side, center, and right side. Or if this is the wave, this is the wave of incident, E is less than V, particle moving in this way. So this is the exponential decay, and then this is something like this. Here it is x, and this is y. This point is V0. This point is V0. So this is A e raised to the power I alpha x. Here it is C e raised to the power beta d or beta x. And here it is A dash e raised to the power I alpha x. So this is the exponential. This is the exponential, and this exponential is beta. And this beta is something that is beta decay, or the wave functions, that is the wave function psi Lx here, and it is psi central, and this is psi right. These are the wave functions in this case. Now we can have some examples. The first example is, if we take the potentials of the different shape, find the probability of an electron with energy tunneling energy tunneling through a potential barrier of width d and height v0 in the given shape. The given shape. What are the shape? First is standard shape. This one is. The second one is this. And the third one is something like this. Something like this. So this is 0, here it is d. This is 0, here it is d. This is 0, here it is d. This value is v0, 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 the top value. So solution. The probability P of tunneling can be expressed in all cases as, what is P? Exponential 2 upon h cross under root 2m v minus e into dx. And integrating this from 0 to d, integrating this, x1 is equal to 0 and this x2 is equal to d. x2 is equal to d. So this value is very simple, and this is exponential. This is minus 2 beta d, where beta is equal to 2m upon h cross square v minus e, as the case we have discussed. Now in this case, for second, this is the first case that have the first case. For the second case, the potential is written as, how it is, Vx is equal to V0 by D. This is the variation of potential, V0 by D into X, V0 by D into X. So the probability is exponential minus 2 by h, this is 2 by h cross, 0 to d, 2m Vx minus e, into dx, So what we have to do, we have to integrate this one is by substituting Vx की ये वैल्यू को सब्स्टिट्यूट करके इंटीग्रेट करेंगे, और इंटीग्रेट करने के बाद जो फाइनल एक्सप्रेशन मिलेगा उसको हम लिख दे रहे हैं, दिस इज माइनस 8d अंडर रूट 2m अपॉन 3h क्रॉस स्क्वायर v0, and this is v0 minus e. This is v0 minus e 3 by 2. This is the probability. सेकेंड केस। थर्ड केस के जो पोटेंशियल होगा, दिस पोटेंशियल Vx is equal to V0 1 minus x square upon d square, x square plus d square। और इसी पोटेंशियल के एक्सप्रेशन को हम स्टैंडर्ड इक्वेशन भर के और फिर इसको इंटीग्रेट करेंगे। तो इसको अलग से इंटीग्रेट करने के लिए दिस इज इसको अलग से इंटीग्रेट करने के लिए दिस इज प्रोबेबिलिटी is equal to, this probability is equal to exp minus 2 by h cross integral 0 to, yeah, this is minus d2 plus d minus d2 plus d under root 2m. This is vx minus e, this is dx. So the Vx is equal to V0 1 minus x square by d square. So this one is dv is equal to V0 1 minus 1 is 0 minus 2x dx upon d square. So this dx is equal to minus d square dv upon 2v0x, 2v0x। और इसको हम यहाँ पर रख करके, इस फंक्शन को रख करके और इंटीग्रेट करें आफ्टर सॉल्विंग दिस इंटीग्रल, after solving this integral, the probability is given as P is equal to, this is pi d upon h cross, this is 2m v0 minus e, v0 minus e. This is the probability. So by the change of different wave shape, we have different type of the probability. Now another example, hello,
good afternoon. ये दोनों लिफाफे रेडी है सर, संगीता मैडम वाला और प्रियंका मैडम का।
हम ले लेते हैं क्लास में अभी।
अच्छा अच्छा।
Calculate the probability of transmission of a particle of mass m is 1.6 into 10 to the power minus 24 gram through the rectangular barrier. The rectangular barrier as V0 is 2 eV, energy of electron is 1 eV, and barrier width is 2 angstrom unit. So solution, the probability is given as T is equal to 16 E V0 minus E upon V0 square e raised to the power minus 2 beta D, where beta is equal to 2m upon h cross square v minus e. This is your beta. तो इसमें वैल्यू रख दिया जाए 16 E. E is 1 electron volt. So 1.6 into 10 to the power minus 12 erg. This is erg. Electron volt is converted into erg. And then V0 minus E, 2 minus 1. So this is 1. So 1.6 into 10 to the power minus 12 erg. Again, this is E and V0 E. And then it is divided by V0 square. V0 square is 2V. So 2 into 1.6 10 to the power minus 12 erg square. 12 erg square. And then exponential. This is 2 beta. Beta is 2 into 1.6 into 10 to the power minus 24 upon h square. H square means 1.05 into 10 to the power minus 27 whole square. And this is V minus 2 E minus 1 E, so 1.6 into 10 to the power minus 12 erg. This is. And then D is equal to 2A, that is multiply 2 into 10 to the power minus 8. This is 2 into 10 to the power minus 8. So what we find, if we solve, this is the square term of this. So your both term has been cancelled. This is 2 square 4, cancel, this is 4. So here it is 4 exp, and this is, you see this is 2, this is 2 minus, here it is 2 into 1.6 ka whole square into 10 to the power minus 24, 10 to the power minus 12 upon 1.05 into 10 to the power minus 27 whole square. This is the beta, and then 2 into 10 to the power minus 8. This. And by solving, this is 4 into e raised to 10 minus 43. This is T. So this is the answer. That is the calculate the transmission probability. So this is the transmission probability of the electron finding after 2 angstrom. So this value is here. Now some if we calculate with the objective MQ, multiple choice question, if you take the multiple choice question, with which of the following phenomena, ये जो प्रॉब्लम्स हैं ये गेट के लिए हैं या जेम के लिए, कैन बी एक्सप्लेन्ड बाय टनलिंग इन क्वांटम मैकेनिक्स. A alpha decay, B beta decay, C field emission, of electron from metal, and D tunnel diode. Answer is A, C, and D. A, C, and D. A, C, and D. These are the based on the tunneling. This beta decay is not explained with the help of tunneling. It is explained on the basis of uncertainty principle, and that's why it is the wrong question answer. The next MCQ is what fraction of a beam of electron each of energy P is equal to 0.08 electron volt reflected from a step potential barrier with height V is equal to 0.06 electron volt of infinite width. So something like this. This is the infinite extending to infinite, and this is 0.06 electron volt, and the particle has energy is equal to 0.08 electron volt. So the solution is very simple. Fractional part is explain E minus V upon V. So this is 0.08 minus 0.06 upon 0.06. That is 2 by 6, 1 by 3. So the 33%. This is the 33%. And there are answers. Options are given. A is 11%, B is 33%, and C was 67%, and D was 89%. So this B option is correct here. तो इस तरीके से कुछ प्रॉब्लम्स हुए, और कुछ ऐसे भी प्रॉब्लम है जैसे सेमीकंडक्टर के केस में, जैसे सनशाइन के केस में, जैसे ऑप्टिक्स के केस में, जैसे एटॉमिक क्लॉक के केस में, और जैसे टच स्क्रीन के भी केस में. तो टच स्क्रीन में एनर्जी उतना ज्यादा इन्वॉल्व नहीं होता है, बट द कंसेप्ट इज द सेम, और उसी तरह से फिर इसमें भी क्लियर होता है. सो दिस इज all about the tunneling, quantum tunneling. Our next topic that we will discuss on the next term is hydrogen atom problem. And here it is the